Good morning, students. In previous sessions, we have discussed about the linear motion and we have discussed friction. In the last two videos and all, we have discussed the types of friction and the friction, how the friction occurs and how to reduce the friction, this thing and all we have learned in the previous video. Already we have studied the linear motion. We have analyzed the linear motion by using the Newton's laws. Now we are going to have a new session, that is what we are going to study about the circular motion more detailed. This circular motion is very important for us because in our daily life we came across so many circular. We are came across. For example, you are traveling in a bike. You are traveling in a bike in a curved road. So there we are using circular motion. That's what in our daily life we are using such type of, we are going through such type of motion. So this circular motion we can analyze by using Newton's laws. So listen here. You know the linear motion which is happening with or without the external force. That is what in the Newton's first law he said. So with or without an external force, this linear motion can occur. But when we are going inside this circular motion, it is not possible. It is not possible to form a circular motion without a force. So there is no circular motion occur without the help of force. That is what we are going to study. So if a force is applied on the object, the velocity of the particle can change. Direction of the particle can change. So here we are going to discuss how a force can change the velocity of the particle. Here three ways given in your textbook page number 147. Dynamics of circular motion, this is the topic. So here three ways is given to analyze how the force can change the velocity of the particle. In that first way is, assume that an object which is dropping down. For example, here I have a chalk. This chalk I am dropping down. When it is dropping down, this chalk moves downward. The velocity is not changing, so you can tell that linear motion. Linear motion. So during this motion, the magnitude of the velocity can be changed, but the direction of the motion cannot be changed without an external force. That is what the first motion. So linear motion happening, that is what linear motion which is happening without the external force. So when you are dropping, now you are not applying any external force on this. If you are applying external force on this chalk, its direction changing. So the motion is changing. It is not linear motion. That is what very important. A force. A force can change this a force which is acting on linear motion. With the force or without the force also, this linear motion is occurring. That is what here it is proved. That is what the first way. The magnitude of the velocity can be changed without changing the direction. So here when you are dropping this chalk downward, any object which is falling downward, its velocity is increasing. So velocity is changing. Velocity is changing, but the direction of the particle is not changing. This is the first thing, first point. And now the second point is, we say, assume that one object, one particle like this. This is the velocity of the particle. So, the same velocity, it is moving, but the direction is changed. Again here the velocity the same, again the direction is changed. Again the velocity is same, direction is changed. Velocity is same, direction changed. So the velocity of the object, the velocity of the particle cannot be changed without but the direction of the, what is happening? The direction of motion can be changed, then we get what? We get a circular motion. This is what we are saying, uniform circular motion. So you see, the velocity is same at each point. The velocity is same, but the direction of the motion of the particle is changed. So we get what? We get a circular motion, or we can get what? Uniform circular motion. This is the second point, and the third point is, you see, suppose this is an object. An object is tied, a particle is tied by using a string. Now this particle is allowed to move. When this particle moves, it moves with some velocity. Here 0 velocity, here increasing velocity, here again decreasing the velocity, here again 0 velocity. Now this particle changing its direction this side. So this is what we are saying, the third way, non-uniform circular motion. Example, you can tell a simple pendulum. So you see, velocity 0 here, velocity increasing, again velocity becomes what? Decreasing, again it becomes 0. Now from here, what is happening? It changed direction. So this particle changing direction, so it will go what? Non-uniform circular motion. So this is what the dynamics of circular motion. There are three ways what a force can change the velocity of the particle in three ways. The first way is what? Any falling object which is vertically downward, it can change its velocity, but the direction of the motion is not changing. That is what? A linear motion which is happening with or without the external force. And the second thing is, the direction of the motion alone can be changed without changing the direction, without changing the velocity, magnitude of velocity. So what will happen? Uniform circular motion. And the third thing is what? During the direction of the motion as well as the magnitude of velocity, both can be changed, then we get what? Non-uniform circular motion. So these are the three ways. Now that is what some explanation about this circular motion. Now we have already studied in uniform circular motion. What? Uniform circular motion, there must be, in any object which is moving in circular motion, there must be some centripetal acceleration. That is what we have discussed in the last video. Centripetal acceleration, CP. Yeah, CP. Centripetal acceleration is equal to V square by R. A is equal to V square by R. This is what we have discussed. Centripetal acceleration, A is equal to V square by R. Now, listen here. So, when an object, any object which is accelerating, so assume that on bike, no need this chalk. Throwing this chalk, now the chalk is accelerated. So, if this is accelerating means, what is there? A force. I applied a force. So, a force is needed. So for centripetal acceleration, there must be some force acting on it. So centripetal acceleration we have studied any object which is moving in circular motion. There is what an inward acceleration. No? So if there is a centripetal acceleration during circular motion, there must be some force acting on it. This force is called the centripetal force, which is acting inward. So any object which is moving in circular motion, there must be a centripetal force which is acting inward through its center. This is the center of circle. So inward force acting. So there is an inward force which is acting through the center of circle. That is what we are saying, centripetal force. In our daily life, there are so many cases we can see. This is what for this centripetal force. So this is what there in centripetal acceleration we have discussed in our previous lesson. So if there is a centripetal acceleration, there must be some force. There must be some force which is acting to its center. That is what we are saying, centripetal force. So the inward force which is acting to the center of the circle, that is what we are saying, centripetal force. As we know, the centripetal acceleration A is equal to V square by R. A is equal to V square by R. So by analyzing this centripetal, this circular motion by using Newton's second law, so apply Newton's second law, F is equal to mk. F Cp you can give centripetal force. So this is centripetal acceleration. So F Cp is equal to m. Instead of here, what we can put on V square by R. This is centripetal force. This is the centripetal force which we get by analyzing this circular motion using what Newton's law. F Cp is equal to mv square by R. We can write this equation in terms of vector form. So F vector equal to m v square by R cap direction. So from this equation, for angular circular motion, we can write this equation in terms of angular circular motion. We know that V is equal to R omega, angular circular motion. So substitute this R omega here. So F Cp equal to m R square omega square by R cap is equal to R cancel. So what will get F Cp equal to m omega square R cap. This is what for angular circular motion. So again, listen here. We know that centripetal acceleration A is equal to V square by R. So in terms of centripetal force, we are analyzing this circular motion by using Newton's second law. F is equal to ma. So instead of A, you can put V square by R. So what will get m V square by R. So substituting this V square by R in terms of acceleration. So this V square by R, substituting here, we get this equation. Now this equation we are writing in terms of what? Vector notation. That is what this equation. Now we are writing the same equation in terms of angular circular motion. We know V is equal to R omega. So instead of V, we can put what? R omega square V square. Now R cancel. What is remaining? M omega square R remains. So this is what equation we are using for angular circular motion and centripetal force, we are using this equation. Now, listen here. This centripetal force is what? We have to know about this. What is this centripetal force? There is a force which is acting toward the center of the circle. We have learned from where it is rising. From where this centripetal force is rising. That is what we are going to discuss now. You know, this centripetal force it is not like our normal force. It is not like our gravitational force. It is not like our tension in the spring. So tension, it is not like a tension force. It is not like a Coulomb force. The centripetal force is provided by all these forces. These forces means gravitational force, tension, then what are? Coulomb force, frictional force. So these are the forces which is providing what are? Centripetal force. So the centripetal force is one actual force, but provided by what are? The gravitational force, frictional force, or Coulomb force. Then tension also one force. Any what are? Object which is tying tightly, there is a tension producing. That tension, that is what a tension force. Tension, yes, it is also a force. So the centripetal force is provided by what are? Gravitational force or tension or what are? Frictional force, or we can call Coulomb force. Coulomb force will we will study in 12th grade. So now we can discuss some of the cases. How an object provide this centripetal force. For example, first one, whirling motion of a stone. Whirling motion of a stone means what? You are tying a stone in a row and just rotating. We know that during this whirling motion, what will happen? There is a centripetal force which is acting towards his hand. When we are rotating like this, there is a centripetal force which is acting towards the center. So this force is provided by, who is providing this force? Yeah, tension. Tension in the string. So the tension during this whirling motion of a stone, the tension produced in the string provides what a centripetal force. And another example in page number 149, you can see the diagrams. Whirling motion of objects in the amusement park. We all have that experience, sitting and rotating giant wheel, and in top chair also we are sitting and very fast it will rotate. There also there is a centripetal force which is acting towards this center star. So this centripetal force is provided by who? From where the centripetal force is getting? That centripetal force is also provided by the tension in the string. That is what the first case. And the second one is satellite moving around the earth. You know, there are some satellites which is moving around our earth. So all these satellites which is moving around the earth, you know, some few distance around our earth, these satellites rotate. So all these satellites moving around our earth, it is acting what force? There is a centripetal force which is acting from the satellite to our earth. This centripetal force is provided by the gravitational force which is acting from the earth. So we can write the equation F is equal to what? Yes, gravitational field, gravitational force. So F is equal to mv square by r. Here mass means what? M mass of satellite, v what? Velocity of speed of the satellite, and r means what? Distance from what? Distance of the planet from the earth. Okay. So this equation we can use in this case. What case? Satellite which is moving around the earth. So here the centripetal force is provided by the gravitational force of the earth. This what this satellite can move in circular motion. And the next one is car is moving in a circular road. When a car is moving in a circular road, there is who is providing this centripetal force. You know, a car is moving in a circular road, so circular motion. Who is providing this centripetal force? That is one. So when this car moving on a circular road, the friction between the car tire and the road, the friction between the surface of the road and the tire. So the frictional force is providing centripetal force here. So the same equation we can use F is equal to mv square by r. Frictional force. F means what here? Frictional force. And m means mass of the car. V means speed of the car. R means radius of curvature of the track. Same page number 149 it is given. So this is also a 5-mark question. We can just go through the centripetal force and all these cases. And the next case is in a curved road. Like these curved roads are there. In our places so many curves are there. So when this car turning on this curve, so there is a frictional force which is producing between what are the surface and this what are tire. So this frictional force provide what are centripetal, enough centripetal force. So that is another one case. And the next case is, the last case is planet which is moving around the sun. So here, you know that planets which is moving around the sun. When this planet moves around the sun, from where this planet gets its centripetal force. So when this planet moving around the sun, the gravitational force from the sun provides centripetal force. Enough centripetal force. In this case, you can use the same equation. What F is equal to mv square by r. So all this motion we can analyze. All this example we are analyzing the circular motion by using Newton's second law. So listen again. Centripetal force means what? Centripetal force means what? An inward force. A force which is acting inward to the circle to its center. Okay, so you know the centripetal acceleration equation is equal to what? V square by r. If we are analyzing this motion by using Newton's law, we can write F is equal to ma. So Fct is equal to ma. Instead of a, you can substitute this v square by r. So Fct is equal to what we will get? mv square by r. Write this equation in terms of vector notation. So F is equal to mv square by r cap. Now we can write the same equation in terms of angular circular motion. So v is equal to r omega. So in terms of v, you substitute r omega. So here v square, so what will come? R square omega square. So r cancel, remaining 1r. So F is equal to m omega square r cap. This is the equation we are using for angular circular motion, and the centripetal force F is equal to mv square by r. We are using the equation. Now, it is very important to know this where the centripetal force is coming. The centripetal force is not like the normal force, like gravitational force, tension, and all other forces. This centripetal force is provided by this gravitational force and water tension and water frictional force. For that, some cases given. First case, what? The wheeling motion of a stone. During the wheeling motion of a stone, what are tension provide centripetal force. The same during amusement park and all, the wheeling motion of the objects. There also what are tension in the string provides what? Centripetal force. And the second thing is the motion of a satellite around the earth. During the motion of satellite around the earth, the centripetal force is provided by the gravitational force on the earth. And the third one is, next one is car. When the car is moving in circular road or in a curved track, in both cases, what the centripetal force is provided by the frictional force. And the last one is planets which is moving around the sun. Here, the centripetal force is provided by what? The gravitational force on the sun. So, my dear students, you can see, refer the page number 147 and 148. Here you mark the centripetal force 3.7.1. So this is what a small derivation and this case you can study. And based on that, example 3.22, you can practice this example 3.22 and 3.23. Do this as your homework. So practice by sitting. If you how many times you are writing, that much knowledge you will get. So my dear students, sit and practice this problem. This 3.23 example 3.23 is very important problem which can be asked in some exams. So see you all. Bye.